Welcome to Natural Habitat Adventures Daily Dose of Nature. Today's topic, the romantic lives of bears, presented by wildlife biologist Aaron Bott. I'm your host, Rob Mess. Thank you all so much for joining us here today. Over to you, Aaron.
Thanks, and thanks everyone for tuning in. Um, I decided to give a presentation on the romantic lives of bears because right now, for most bear populations in the northern hemisphere, we are just wrapping up breeding season. Um, Typically at this latitude, I'm at the 45th degree. We have bear populations throughout the Yellowstone area as well as throughout the rest of North America, but extending even all the way up into the Arctic. Polar bear, black bear, and grizzly bear populations are just concluding their breeding season. And so I thought for those of us who are going to get out in the field and explore bear habitat this year, it might be interesting for us to know exactly what's going on, specifically regarding the reproductive cycle of these incredible animals. So without further ado, as I was introduced, my name's Aaron Bott, and I am a wildlife biologist, and I specialize in large carnivores in North America, particularly wolves, but I've also spent a lot of time working with various bear species, mountain lions as well, and yeah, I'm happy to be talking to you all today. This is kind of an interesting subject. We are going to be talking about sexual behavior in animals. Nothing too graphic, but nevertheless, it is something that might get us into the weeds of jargon. The biology of sexual reproduction can be a little bit confusing and overwhelming when we look at it through a biological lens, but I'm going to do my best to try and water everything down so that we can understand just how unique bears are when it comes to how they reproduce and how they thrive on the landscape. So I think with that caveat, we'll jump into their origins. It always helps for us to understand how an animal behaves and better understand its ecology and biology if we go back in time a little bit and look at their evolutionary history. Particularly what we as biologists we call phylogenetics, which is looking at how a species evolved in relation to other species out there and how they're related genetically. So in the animal kingdom, we have the order Carnivora, which many of us probably are familiar with. Carnivores eat meat. That's what carnivore means. They're the flesh eaters. And this order has animals that vary from extinct saber-toothed cats down through your lions, your dog family, your bear family, your sea lions and seals, your raccoons and your weasels, etc. But all of these animals have several things in common. One of the most iconic is their teeth. These animals all have some form of carnassial, which is a specialized molar and premolar at the back of the mouth, which are used to scissor through flesh. And I've talked about foraging behavior in wildlife before, but I'll point out that it's very advantageous to consume meat if you're an animal because meat is easy to digest and it has a lot of nutrients, and a lot of that nutrients can be conformed into energy and into one's own physical mass and overall health. So eating meat is great, again, because it's very nutritious and it's easy to digest, not a lot of energy expended during the digestive process. However, meat is also challenging because you have to catch it, and sometimes you don't catch it. So comparing carnivores to other herbivore species, such as your foregut fermenters and your hindgut fermenters, like horses and cattle, for example, or deer and elk and bison, those animals are taking advantage of resources that are commonly found in their environment, namely plants. But plants are difficult to digest, and it takes a lot of consumption of plants to get the appropriate amount of nutrients needed for the body to operate and function. So you've got kind of this arms race between the predators or the carnivores and your herbivores. And in some cases, being a carnivore and pursuing your prey is just very challenging. And there's a lot more misses than hits. And you don't have a lot of success per se when it comes to hunting. And so certain groups within the order of Carnivora, certain infraorders of the carnivore order, have developed specialized carnassials that have talonids or a platform, a molar platform, which allow them to have a more dynamic diet. They can consume not just meat, but in some cases they can also consume plants. And as is the case with bears, these animals become omnivores. So bears are omnivores. Polar bears are the only obligate carnivores in the ursid group. Nevertheless, they're still considered carnivores. And you even have panda bears, which are strictly herbivores. They only consume bamboo, of course. So I think that this kind of helps us to understand that bears are related to wolves and to mountain lions and other carnivores on the landscape. But when it comes to their reproductive cycle, we need to understand exactly where they're coming from and how their foraging behavior can influence their overall reproduction. So for bears who are omnivores, they depend on plant material in order to grow and also to provide enough nutrients and be physically fit enough to reproduce. And so for many bears, their reproductive cycle has to coincide with what we call the phenologic cycle, or the plant growing period, the plant growing season. So in the springtime, many animals throughout the northern hemisphere or in temperate ecosystems, they generally will start to give birth to offspring in the spring, when there's a lot of food resources on the land, capable of supporting not only the mothers, but also the young as well. So bears have this adaptation where they synchronize their reproduction so that their cubs come out of their dens in the springtime so that they can romp around with mom and they can eat a lot of vegetation as well as consume meat from other vulnerable species on the landscape, such as deer and elk, newborn deer and newborn elk, for example. So bears have been around for a long time. They really first began to originate back in about 35 million years ago, and they looked very different than what we would recognize bears as looking today. Many of them were jackal-sized and looked more like dogs than bears. But over time, the 8 bear species that we have today eventually evolved into their own individual species. But exactly when these different bear species broke apart from one another in terms of evolution is difficult to truly pin down. And a lot of this is because there's been ancient hybridization between these bear species that really complicates the evolutionary story. So we know that the polar bear is perhaps the youngest bear species. It evolved about 600,000 years ago, maybe as far back as 1 million years ago, but it diverged from the grizzly bear or the brown bear species, Ursus arctos. But over the last at least 150,000 years, polar bears and grizzly bears have constantly hybridized. They produce offspring, which complicates, again, the DNA and the gene pool when we go back and we're looking at the evolutionary story of these bears. But I think it's important to again point out that bears have a lot of similarities, which comes into play, especially in terms of their unique reproduction. So today we have 8 species of bear across the world. In North America, where I live, we have the grizzly bear or the brown bear, Ursus arctos. We also have the polar bear, and we also have the American black bear. But across the pond, we've got panda bears, which are perhaps the most unique among all of the bear species. A lot of the rules of reproduction that we're going to be talking about today don't quite apply to panda bears in the same way. But we also have sloth bears and sun bears and Asian or Asiatic black bears and speckled bears. And all of these bears, again, as omnivores primarily, exhibit really unique ways of reproducing. And a lot of this, again, comes back down to diet. So I'm going to take a case example of the Yellowstone grizzly bear for just a minute. So Yellowstone grizzly bears have the highest concentration of protein in their diet of any bear species or population on the planet. They eat about 40% meat, and the reason why their protein-rich diet is so high in the Yellowstone ecosystem is just because the biomass of other animals is so great in that area that it's easy for bears to scavenge on meat and therefore consume a lot of protein. Nevertheless, 60% of their diet is plants or vegetative matter. If you look at other grizzly bear populations across the world, the proportion of plants in the diet increases dramatically, up to even in some cases 90%. And if you look at American black bears, again, it's generally 80 to 90% plants in their diet. And not all bears have sexual maturation at the same pace or the same speed, but again, I think it's important for us to take a case example of bears, grizzly bears here, and recognize that bears generally reproduce very slowly. So for grizzly bears specifically, their reproductive age of maturity is generally between 5 and 6 years for females. So it takes a long time for a female to be on the landscape, growing and maturing before she is actually going to be producing offspring, which is going to help facilitate for offspring recruitment in that population. And bears are also very good mothers, generally speaking. They take a lot of time investing care into their offspring to ensure their overall survival. And for grizzly bears, it's about 30 months of babysitting her offspring to make sure that they grow up and live to be adults and have a shot at life, basically. Now, again, all of this varies depending on our bear species that we're looking at. For black bears, reproductive age of maturity is generally younger. It's typically 3 to 4 years old. Maternal care is generally closer to 2 years rather than 3 years. Nevertheless, bears are what we often call a K selection species, which are like humans. It's just a complicated way of saying that they are species that generally invest a lot of time and care in trying to ensure the overall success of their offspring's survival. And then there are many species that are what we call R-focused in terms of selection and reproduction, where animals reproduce very quickly, like rabbits, or better yet, like frogs, and they produce a lot of eggs and a lot of tadpoles hatch, but not a lot of those tadpoles actually reach full maturity. So different ways of adapting to reproducing on the landscape in order to ensure that your offspring are gonna make it to maturity. This graph right here is a list of placental and non-placental mammals in terms of reproductive rates, and you can see that that red dot over by the 600 at the bottom of the graph is indicating that grizzly bears have really low reproductive rates. So they're the opposite of rabbits, you could say. It takes them a long time in order for their populations to grow. And again, that's just because they reach sexual maturity at a much slower rate than many other animals out there. And also they invest so much time and effort in trying to help their offspring reach sexual maturation. And again, I've touched on this a bit, but everything really boils down to food. Foraging or looking for food is arguably the most important animal behavior out there. If you can't eat, if you can't get enough resources, if you can't get enough nutrients, then you're not going to be able to sexually reproduce successfully. You're not going to have offspring because your own biological needs will not be met. And if you do, reproduce, then your offspring are most likely not going to make it because they won't get enough food, either from mother's milk later on or when mother's trying to teach them to forage. So this is another case example with the Yellowstone grizzly bear, showing how dynamic diets can be and how important the flexibility of these diets needs to be in order to support the overall recruitment of offspring in a population. So grizzly bears in the Yellowstone ecosystem eat everything from army cutworm moths to pine nuts to Yellowstone cutthroat trout to different biscuit roots and forbs. And of course, they also will take advantage of newborn herbivores on the landscape. There's a lot of elk in the Yellowstone ecosystem, and when elk babies hit the ground, bears like to take advantage of those tasty snacks. And all of that ultimately increases the odds of reproductive success. Now, bears also have to time what they're doing according to their environment. And for many bears, they live in temperate ecosystems where there are 4 seasons. Because many bears live as herbivores and they depend on plants for nutrition, and plants are buried in the wintertime, bears undergo a metabolic adaptation, which allows them to wait out the hungry season, which is winter. And bears go into a unique form of hibernation. And in that period of hibernation, they're waiting until the plants come back, and also waiting for newborn herbivores to be on the ground for them to munch on. And it's at that time period that bears come out of their seasonal torpor and they get ready to reproduce. So in the Yellowstone ecosystem, we're generally looking at bears emerging from their dens, males coming out first in March, and then females in April, and females with cubs as late as the beginning of May. And this is fairly consistent across the board, but all of this is generally based off of photo periods rather than seasonality. So it's the light of the sun that is affecting the hormonal balance of these animals and dictating when it's time to get ready to reproduce and when it's time to get ready to go into hibernation. So pretty much across the board, the reproductive season for bears is generally between May and June, and sometimes into the beginning of July. So whether you're a polar bear, or whether you're a black bear, or whether you're a brown bear, your reproductive season is timed right at the beginning of summer. And again, this is an excellent opportunity for bears to get together and to, for lack of a better word, socialize. Bears typically are solitary. They don't congregate in sloughs, is what the word is for a group of bears. They only usually congregate in large groups around areas where there's a lot of food resources that doesn't demand a lot of interest-specific competition. So bears that are at excuse me, that are at streams where there's a lot of salmon swimming upriver, bears can congregate there and they don't have to worry about competing because the resources are so abundant, and therefore they're more tolerant of one another in those kinds of areas. But in the early summer, in May and in June, bears start to come out of their dens. They start to pack on a little bit of weight after having lost it all during hibernation. And they walk around looking for mates. And I think it's important for us to realize that, as for most mammals, the energetic investment of rearing offspring is much larger for females than males. Male selection, therefore, is much more important for a female than it is for a male. Females are the ones that are going to be raising the offspring without any help from the father. They're the ones, therefore, that need to make sure that they're going to be selecting a mate with the most potential to produce healthy offspring. And males, on the other hand, generally being solitary, typically wander off throughout most of the year, and they are naturally larger than the females. And this is because of what we call sexual dimorphism, which is again common in many mammals, where the males are typically larger. The reason why they're larger generally has to do with competition for mates. Females are ultimately a limited resource on the landscape. There are only so many females which are capable of reproducing in a given season. Some of the females are not quite sexually mature yet. Some might have cubs, and females with cubs are not sexually receptive. And so the males on the landscape are generally going about and they are looking for viable females. And females can signal their sexual receptiveness by having chemical signals emitted in the landscape. And this can be through several ways. It can be through generally the emission of excrement, urine specifically, or fecal matter, but also bears can communicate through chemical signaling, by rubbing their sebaceous glands, their oily fur glands, on different scent marking posts such as trees. And there's a lot of videos out there that kind of caricaturize this behavior. Bears talking to one another about what other bears are on the landscape and what sex they are and what stage of sexual availability they might be in preparation for the breeding season. So chemical signaling works for females because the female is able to advertise her reproductive state if she is receptive, to reproducing that season. And it's also important for males to communicate with one another to know who else is in the neighborhood and who they might potentially have to be fighting with to compete for reproductive rights, for breeding rights with females. So all of this again comes down to a pretty unique dance between males and females communicating with one another on the landscape before everything boils down to what we call intrasexual competition, where males are competing with males aggressively for the opportunity to breed with specific females. During this period, males are battling one another, and as they fight and battle one another, things can be pretty vicious. Generally, physical competition doesn't escalate to the point of mortality, but bears can be injured severely as males compete with males for breeding opportunities. And in some cases, especially with older bears fighting younger bears, younger bears might die. They might be injured or crippled as they fight older bears for the opportunity to breed with females on the landscape. Again, this is why it's so important that bears have chemical signaling, because females are wanting to ensure that their energetic efforts for going through an estrous cycle or a reproductive cycle is not wasted. But males are also trying to reduce the risk of of competing for physical contests. And in many cases, if a male is much more mature and well established, larger, and more aggressive in an area, then other bears in in the neighborhood are going to be less likely to compete and ultimately fight for breeding rights. In fact, most male bears do not breed in any given season. It's very much monopolized by the biggest and the baddest and the toughest bears on the landscape. Females, in terms of their biology, which I think is very interesting, is female bears have what's known as sequential ovulation. So like most mammals, bears are seasonal breeders, in contrast to humans, which are continuous breeders, right? People can breed any time of year, but bears have just a narrow window where, based off of the photo period, the available sunlight, as well as foraging opportunities, the food and the resources available on the landscape, bear hormones kick into gear and females can reproduce or are receptive to reproduction only in a narrow window. Generally, it's for about a month or so, a month to 5 or 6 weeks. But females have what's pretty unique in terms of the carnivore order, where female ovaries are basically kept protected in a bursa or a fluid sac, which reduces the chance of egg loss and also increases the chance of successful fertilization with other males. But bear ovaries also frequently release multiple eggs, and with the exception of the giant panda, they can ovulate sequentially during the mating season. So rather than just producing or ovulating one ova at a time, there's constant production of ovas or of eggs throughout the entire breeding season. And this is really important because it ultimately ties in with multipaternity litters, which I'll talk about in just a second. Excuse me, got a cold today, so I'm a bit under the weather. So when females go into heat and then when they start to breed with males, they're continually producing eggs. And generally what happens in a lot of mammals is you have, after ovulation, the corpora lutea hormone, this uniquely designed hormone which secretes primarily progesterone and creates a very hospitable climate in the uterus for the embryo to finally fertilize, or for the embryo to finally develop and attach to the uterine wall and ultimately develop into a fetus, is ultimately delayed. So we have what's known as CL dormancy. So this hormone is ultimately suppressed by the body, which allows the female to continue to ovulate even if she has successfully reproduced and one of her eggs has been fertilized by a male. And when this happens, we get what's known as multipaternity litters. And this is pretty frequent in wild bear populations that are robust. So female bears generally give birth to multiple cubs in a litter, usually 2 to 3, in some cases 4 for highly fecund American black bears. But it's not uncommon to find bear cubs that have been sired by multiple fathers in a single litter. And again, this is because of sequential ovulation and the CL dormancy, or the deactivation of this hormone while the female is in heat, while she is going through her estrous cycle. Excuse me. Again, I'm sorry about this cold that I've got. So females, because of this hormone, they undergo what's known as delayed implantation. So the egg becomes fertilized, but rather than implanting, the female remains sexually receptive and can breed with other males on the landscape and even potentially become pregnant by more than one male. Bears are generally polygamous, so during this period while they're sexually receptive, they're meeting with other bears on the landscape, and the female herself might not actually become what we call truly pregnant until quite later in the season. So she might have successfully bred with more than one male, and yet her body is not going to kick the CL hormone back into gear until she's undergone what's known as hyperphasia, which takes place generally in the fall, where females are excuse me, where females and males are both preparing for hibernation. So hyperphagia is this period where the bears are consuming a lot of food, a lot of calories in order to get fat and endure a long winter of abstinence where they're not going to be consuming any other food resources for up to 5 months at a time. So at this time, the female is consuming a lot of food and packing on a lot of weight. And if her body can consume enough calories, generally up to 20,000 calories a day or more, and if she can stock up on enough fat reserves, then her body will ultimately accept the blastocyst that has been fertilized, and it will then embed in her uterine wall, and she will then successfully become pregnant months after she has actually been fertilized by a male. And again, this is a really unique trait known as delayed implantation, and there's also embryonic diapause taking place. So embryonic diapause refers to the development of the embryo, moving from the zygote into the blastocyst stage. Everything gets put on pause as those CL hormone levels remain low. Then delayed implantation also is put on the table while the female is constantly not only breeding with other males during the short breeding season, but afterwards trying to get her body in a healthy enough condition to be able to successfully reproduce. And again, if she gets enough fat reserves, then those CL levels that have been reduced are activated, the climate in her uterus improves, and she becomes receptive to taking on those fertilized eggs, now blastocysts, which will ultimately develop into fetuses. And generally for most bear species, it's typically 2 or 3 cubs that she can become pregnant with. Now, all of this is very complicated, but I think it's a really interesting testimonial of just how adaptive species can be regarding their evolutionary characteristics and their environment. So bears have this unique ability as omnivores to eat both meat and plants, and because so many of them depend on plants throughout most of the year, they need to go into a state of torpor or hyperphagia, or excuse me, torpor or hibernation, where they can sleep for 5 to 6 months of the year without consuming any other food. But in order to successfully reproduce, they have to time their biological reproductive clocks to a season where they're all going to be out and about and commingling, which for many bear species is generally the early summer or the late fall or the late spring. Excuse me, my cold is definitely messing with my head today. And as females go into hibernation, generally it's between October and December, their body again starts to reactivate that CL hormone, and she can successfully become pregnant and then gestate her cubs for usually 6 to 8 weeks, depending on the species. So the cubs are generally born in January for most latitudes, and they're born typically hairless and weighing less than a pound. So they're what we call Altruition Young, meaning that they're completely dependent upon the mother. And they will spend the next several months from January through May suckling on the mother's milk and growing to be fat little cute bundles of fun. and then emerge with mother next spring. This is, again, a very cool and unique adaptation that bears have in order to increase their odds of reproductive success. Sometimes we have what's known as pseudo-pregnancies, where everything seemed to have gone right, but for some biological reason or physiological reason, the female was not able to successfully reproduce. Nevertheless, her body goes through kind of this false reproductive preparation or pregnancy preparatory phase where she might start to show all the signs of having been pregnant, but there's actually nothing within her uterus which has been implanted and is developing into a fetus. If she is not able to consume enough calories, if she doesn't get enough fat, then her body ultimately reabsorbs the blastocyst rather than becoming successfully pregnant with it. So that's a lot of complication, and I'm sorry that it took me so long, and I'm under the weather to to kind of explain this more simply, but I do think that bears have a very unique adaptive story in terms of their sexual reproductive life histories. And at this time of year, as you're getting ready to go out into the field and you're thinking about bears, you can wonder in awe just how incredible it is that bears have just finished breeding, but females are not technically in any form of gestation right now. They won't start to have any signs of pregnancy until much later in the year. Generally, again, in November is when things start to kick in, and she will begin to successfully gestate the offspring that are growing inside of her. It's a pretty cool trick, I think. With that, I will take questions.
All right, thank you very much. Now, I'd like to remind everyone that if you would like to submit questions, you can submit your question via the question field in your control panel. All right, let's get to some of these questions. So, do bears have any form of menstruation? Is an egg not fertilized? How does that work?
Yeah, so bears, like most mammals, have what's known as an estrous cycle rather than a menstrual cycle. So a menstrual cycle is generally pretty specific to primates, and humans obviously are primates. So our reproductive cycle is pretty different than most animals. So an estrous cycle is it coincides with a female's body going through a period of breeding preparation where she begins to ovulate only at a specific time of year, compared to, again, humans, which are receptive to reproducing at any time of year. We're continuously reproducing, and excuse me. So yeah, I don't know if that answered your question, but their cycle is different than the human cycle because of that biological suppression throughout most of the year due to the nutritional needs of the mother.
Great, thank you for covering that. So, do we know what percentage of the diet for the Alaska brown bear is fish?
Yeah, we do, and it's pretty high, but it's also all at once, right? So it's when the salmon runs take place, you generally have maybe 2, maybe 3 weeks where the bears are gorging on fish in the summertime, and this helps with retaining a high fat body percentage, which also explains why those bears are much larger than other brown bears throughout the world. But I don't know off the top of my head what the overall percentage throughout the year is.
So, would you say that brown bears in Yellowstone have a higher percentage of protein in their diets than the Alaskan brown bear?
Yes, this is true. They do. It's the protein content for bears in the Yellowstone ecosystem is again based off of the high concentration of biomass. So with how many elk they have, how many bison they have, and how it's scattered throughout the year where they can continually scavenge on this biomass generally shows an overall increase in protein in their diet when compared to other brown bear or grizzly bear populations elsewhere.
Is an unfertilized egg expelled or somehow absorbed?
Yes, it's reabsorbed. So the body will just reabsorb it. And again, sometimes even if the egg is fertilized, as it develops into a blastocyst and remains in that state of delayed implantation, if the female's body is not conditioned, if she hasn't gained enough fat reserves to support her and her potential offspring throughout the spring, then her body will also reabsorb that fertilized egg.
Got it. Thanks for clarifying that. So does the female in the den who has given birth stay awake in the den while her cubs are nursing?
Yeah, so bear hibernation is interesting. We call it hibernation, but it's really something very different from normal hibernation. Bears do something different than other animals, where their body goes into a semi-state of torpor. They don't eat or drink or urinate or defecate for 5+ months, but they do remain semi-conscious. And so when she whelps, when she gives birth to her litter of tiny babies in January, usually, she is conscious for that. And she is capable of responding to external threats as well. So if you ever go into a bear den, while a bear is in the den, they can respond quickly. They are not in a state of comatose.
Got it. Thank you. So on the phylogenetic tree, what is a bear dog?
It's an extinct animal, and it's kind of misleading. Paleobiologists first uncovered the fossilized remnants of this hyper carnivore back from the Pleistocene, so during the Ice Age. It's more dog-like than bear-like, very thick jaws, very strong bones. And yeah, it used to walk around and was one of the apex predators during the Ice Age, but has all gone extinct. So kind of a cousin of the bear and a cousin of the dog.
How many offspring would a bear have during their lifetime?
Well, that's difficult to say. Some bears, like grizzly bears, for example, are only capable of reaching sexual maturity for the females at the age of 5, and they can live, if they're lucky, all the way up to 30. And then they could be reproducing every 3 years. So you've got quite a handful of years that you're successfully or that you're capable of reproducing. And generally, grizzly bears are giving birth to 2 cubs at a time, but because life is hard, usually there's a 50% mortality rate for newborn cubs. And so after the age of 5, every 3 years, a female is putting 1 cub back into the population for the next 25 years. So yeah, 10 cubs probably if she's really lucky. And most bears generally don't live to the age of 30 in the wild, but it's possible. A famous bear known as 399 just outside of Jackson Hole, she is living very fat and very happy, and she's old and has reproduced successfully for a long time now, but she's more of an exception.
Do all bears have a similar reproductive cycle?
Yes, all bears do. There's kind of 2 bear species which are a little bit exceptional, and I am not specialized in their biology, but I'll give it a stab. Panda bears and Andean bears are the 2 bears that are the most genetically and evolutionarily unique. There's 8 bear species: the Asiatic black bear, the polar bear, grizzly bear, the American black bear, the sloth bear, the spotted bear. or the speckled bear, excuse me, they're all fairly close in terms of genetic relatedness. But the panda bear and again the Andean bear, they're a little bit different. Panda bears are not sequential ovulators, for example. I talked about sequential ovulation in most bear females. They have to time their ovulation a little bit more carefully. Also, the gestation period for panda bears is shorter, and so the cubs are born much less developed than other bear species. And Andean bears also kind of show this interesting and even questionable delayed implantation adaptive ability, which doesn't quite conform with the other bear species.
So when a cub dies, do we notice a change in the female's behavior? Does it mourn the cub?
Well, not all the time, not necessarily. I mean, I think that that's kind of an interesting question, but it's difficult to answer because there's a lot of individuality based off of circumstance. There is a lot of infanticide that takes place with bears, and I didn't talk about this. I kind of avoided it just because I didn't want to go on a tangent and get off topic, but I think that it's appropriate to mention it here. So male bears generally will focus their attention on females, but not all females will be sexually receptive, especially if they have cubs. So to encourage females to biologically enter into a state of reproductive acceptance, males generally will pursue and even kill cubs of female. This triggers hormonal responses and physiological responses, which can bring a female into estrus unseasonably early if it's that time of year, whereas she might not have entered estrus for another year or so. Yeah, males are pretty aggressive at killing other cubs, or at killing cubs, and this is also to reduce competition for breeding rights later on as those cubs might mature.
Well, thank you, Aaron. That's the last question that we do have for today. So I'd like to throw it back to you for any closing comments.
Thanks everyone for tuning in today. I apologize, I'm a bit under the weather, and I think that again, this was an engaging conversation, and I appreciate all of your questions, and thank you for your time.
Aaron, thank you so much for taking the time to present for us today. And I'd also like to thank everyone who tuned in today. Now, if you're interested in information on how you can travel with NatHab, please give us a call at the number on your screen, or you can send us an email at info@nathab.com. Our adventure specialists are happy to help you out. Join us Monday for our next Daily Dose of Nature. You can check out next week's lineup, including registration links, on our website at nathab.com/webinars. We did record today's presentation, and we will have the replay available on our website soon. With that, I will conclude the webinar. Goodbye, everybody. We will see you next time.